Okay, this video is going to be our 4.6 worksheet walkthrough. All right. Number one is determining the domains and range of all of our trig functions. I definitely asked this on Unit 2. It just depends on which trig functions you're going to get on your exam. So make sure to know them all. Okay. We're going to go ahead and start with our sine and our cosine. They're going to be exactly the same. Domain, A, all real numbers. Range, E, all real numbers from -1 to 1. If we go back and look at our graphs, you can see your domain, which is your x values, are all of them. Your y from -1 to +1. Same thing here. All real numbers domain, -1 to +1 is your range. So sine and cosine, the exact same values. Let's go ahead and look at our cosecant. Cosecant here, if you notice, we do not have all real numbers here. We actually have asymptotes at the multiples of 0, pi, 2 pi, so at multiples of pi. So our domain here will be B, all real numbers except multiples of pi. The range will be numbers less than -1, including -1, or greater than +1. Okay, so that one will be C, the set of real numbers less than or equal to -1 or greater than or equal to +1. Okay, if we're going to look at secant, which I notice I don't have listed here, secant is going to be very similar. The domain, all of our x's, are going to be all real numbers except the multiples at pi over 2. So that one would be D, the set of all real numbers except the odd multiples of pi over 2. Okay, our range will be the same as the cosecant, which is C, numbers that are less than or equal to -1, as you can see here, -1 or less than, or 1 or greater than. Okay, so the secant will have very similar, except the domain is different. Okay, for tangent and cotangent, tangent, you're going to have domain of all real numbers except the odd multiples of pi over 2. So here we're looking at tangent, that's going to be D, set of all real numbers except odd multiples of pi over 2, and then our range here can be all real numbers, which is range, all real numbers. Okay. Okay, for cotangent, here you have all real numbers for your domain except at pi. Okay, so we're looking at over here, that's B, all real numbers except integers multiples of pi. Okay, and then our range is going to be all real numbers, which is A. Okay, next one. Okay, you're going to have here matching graphs. Okay, there was a typo in this part. This is supposed to be pi over 4. Okay, it's very unusual that Alex has a problem incorrect like this, but it did in this case. So the very first thing I suggest, and I just wrote down all of your tips here, is start with the graph. Here we're looking at where the asymptotes are. Asymptotes are at -pi over 4 and 3 pi over 4. Okay, so I said since the asymptotes are not 0 and pi, that's for cotangent, or -pi divided by 2, +pi divided by 2, which is your tangent, it's going to tell us that there's a horizontal shift. The period here is still going to be 1 full pi, so we still don't quite know which one it is. But this helps us narrow down the basic cotangent and the tangent asymptotes. Okay, that means there has to be a shift, which only leaves this one over here. Okay, here it's pi over 4. It says plus, so that means it's going back. And then the direction for cotangent is correct. Remember, when we're looking at cotangent, I'm going to go back to the graph here. When we're looking at cotangent, we're looking at quadrants 1 and quadrants 2. Cotangent's positive, cotangent's negative. So if we start at 0, we're going to have a function that is positive, and then it goes through 0, and then it's going to go into a negative value. When I'm looking at my asymptote here and going forward, my y values here are positive, crosses at 0, which is the midpoint, and then I have y values that are negative. So for this one, this is the only option that's correct. Okay. All right. For the next one, what I ended up doing was drawing the trig function that corresponds to this specific graph. I determined that the period is pi over 2, which means b is equal to 1. I also look at the a from the center to the top. That was a distance of 2. Okay. I put this little positive right here to determine where the origin is, and if you notice, if this is the origin, this is a negative value, this is a positive value, it starts up. And remember, we use cosine if it starts at the top or if it starts at the bottom. So here we're using cosine. So the reciprocal of cosine is going to be secant. So I'm going to use the 2 from here. The reciprocal of cosine is secant. And then I do not have any kind of stretching or shrinking for our horizontal axis, for our horizontal side. So that means b is equal to 1, and then our answer is going to be this one. Okay. Right. Moving on to the next one. Here you can see I drew the top, the center, and the bottom. Determine a is again 2. Okay. And then we're going to look for our origin, which is going to be right here. Okay. When it's right here, you can again see that this is the top. It starts at the top, which means we again use cosine. So the reciprocal of cosine is going to be secant. Okay. Now the difference here is we need to determine what the period is. Okay. The period is going to be the starting point, and I'm going to use the center in this case, and I'm going to determine how long does this take from one complete rotation. So it's taking from this point here all the way over here. Okay. So the period is actually going to be 4 pi, but I want to solve for b. So I'm going to use period equals 2 pi over b, and then I'm flipping these. So I get the pi's cancel out, and I get 2 over 4, which is the same thing as 1/2. Then I'm going to put it all together. Y equals a secant b, and then the x. There is no horizontal shift here. Okay. All right, let's go on to the next question. Okay, number 3. This one says to graph a secant or cosec function. This will be our type 1. So here we have a few things. Okay, let's go ahead and figure out which equation we're going to use first. Okay, remember, always use the reciprocal of whatever this is. So I'm going to rewrite the equation exactly, but I'm using the reciprocal trig function from whatever is given. So negative 2/3, secant, reciprocal is cosine, 3/2 x. Now I know what my a is. Remember, do not include the negative. That's going to be 2/3. And then we're going to have to start at either the top or the bottom. Because this is a negative, we're starting at the bottom. Okay. Then we are going to figure out what the period is. We know that this value is b, so I did 2 pi over b, substitute, and I get 4 pi over 3. Once you have this part, remember we're going to take our sections. We're going to do the period divided by 4. And here I get the sections to be pi over 3. The sections is the part that we're going to add from our original number. So no shifting here at all. So we're going to start at 0 and we're going to add pi over 3. So I didn't put the numbers that I'm adding each time. I just put it the main 5 points. It's similar to the ones that I highlighted in purple. So I start at 0, add pi over 3, I get pi over 3. Add another one of these, I get 2 pi over 3. Add this again, 3 pi over 3. Add this again, 4 pi over 3. All I did from here to here is find a common denominator using 6. Now why did I choose 6? because if I'm looking at these points, it's really hard to tell here, but there are 6 points between 0 and pi. So pi is over here. So if I go through and I counted all the lines, you should be able to count 6 of them. Let's see. 1, 2, 3, 4, 5, 6. And that's 1 pi. Okay. This makes it easy because then I know I have to have a major point at the 2, the second line. That's 1, 2. At the 4, 3, 4. At the 6, 5, 6. And at 8, 7, 8. Those are my main points. Then I'm going to go ahead and draw my cosine function, and then I'll use the maximum and minimums to go ahead and draw my secant graph. Okay, number 4, very similar. We're doing a type 2 problem. Now we're including a phase shift. So the first thing I'm going to do is write the equation again. Here I'm using y is equal to reciprocal of secant is cosine, 3x minus pi. Now what I want to do is factor this 3 out. So when I factor it out, I get y equals cosine 3, parentheses, x minus pi over 3, close parentheses. Remember, this is going to be our starting point. So our very first number here is our starting point. Okay. A is going to be 1. We're going to start at the top because this is cosine and this is a positive value. The next part right here, B is going to be 3. When I substitute, I get the period of 2 pi over 3. Then I'm going to divide that by 4 and I get my sections at pi over 6. Now notice we had pi over 3 as our starting point, but we're adding a pi over 6. So pi over 3 equals 2 pi over 6. Now I can take this 1 pi over 6 and add them. So 1 plus 2, that's 3. 1 plus 3, that's 4. 1 plus 4, that's 5. 1 plus 5, that's 6. These are our 5 main points. Okay. Once again, because there's 12 lines between the 0 and the pi, let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to 1 pi. That's why I changed everything over according to a denominator of 12. Okay, now when you're graphing this one, remember we said we start at the top. Okay, so we're not starting here at the top. We have to do our phase shift. So we're going to go, that negative says go forward. You're going to go pi over 3, which is located right here. And we're starting at the top. Middle, bottom, middle, top. And here, if I'm at the top, if I go backwards, I'm going to go back to the middle, back to the bottom. Okay, so it's going to have that continuous shape. Once you have your maximum and your minimum, you're going to use that to graph the actual function that you're trying to. And in this case, that's going to be secant. Okay, that's number 4. We have 2 more. Here's number 5. Number 5 is going to be a type 1 using tangent or cotangent. Here's our equation. This includes a phase shift. So remember, for tangent, we have to determine where are our asymptotes. Just remember your asymptotes for tangent are negative pi over 2 and positive pi over 2. Because this is in parentheses, we're using the entire thing in the middle. If this was not in parentheses, you would only use the x in the center, and this would be a vertical shift, meaning you go either up or you go down. But because it is in the parentheses, you have to include that negative pi over 2 inside this inequality. Okay, now what we're going to do is isolate the x, so we have to add pi over 2 to both sides of the equation. So negative pi over 2 plus pi over 2, well, that's 0. Positive pi over 2 plus positive pi over 2, well, that's 1 full pi. So my asymptotes are going to be between 0 and pi. So here's my first asymptote, pi, 2 pi, and so forth. Okay. Next thing I'm going to go ahead and do is determine which direction. Now when we're looking at the unit circle, tangent is going to be quadrants 4 and quadrant 1. Well, if I'm starting at the first asymptote and I'm going forward, I'm going to have a negative tangent graph. Then it's going to hit the 0, and then tangent will be positive. So if I'm looking here at an asymptote, my negatives are first, passes through the 0, and then my values are positive. So the direction is going to be in this direction. Okay. Since A is equal to 2, the points that are between the center and the asymptotes, in between the center and the asymptote, which is in this case here, that has to be marked at -2, between the center and the asymptote, right in the middle, and +2. So these are going to be my values. Number 6 is going to be another graph for a type 2 problem, which is, in this case, it's going to be a tangent again. Tangent, -π/2 to +π/2. Everything inside the parentheses goes in the middle. I'm trying to isolate the x, so I'm going to multiply everything by 2. This is not subtraction, it is multiplication. 2's cancel out, leaving us just with an x. 2's cancel out, leaving us with a -π. 2's cancel out, leaving us with a +π. So our asymptotes are now going to be -π and +π. Okay. Period is going to be pi divided by b. b in this case is 1/2. That makes it 2π, and the difference between here and here is 2π. So that's 1π, 2π. This is just a really nice, easy check to make sure that your graph is looking good. Okay. A is going to be 1/2. The midpoint between the center and the asymptote is going to be +1/2. Distance from the center and the asymptote will be a -1/2. So there I put my main points, and then I put it in the correct direction. Asymptote going forward or going up is going to be negative, hits the 0, and then it will be positive, just like our unit circle. Asymptote going up or positive in direction is going to be negative tangent, hits the 0, and then tangent will be positive. So there you go with the complete graph. Okay, that was a quick run through of 4.6. If you have any questions, please let me know.